So let's continue on 8.1. We are trying to compute what the cosine of those two Greek letters are. And notice that I don't have all the information that I need, because in our cosine formula you need the sine and cosine of each of those. And I only have one of them. So over here I'm going to draw some triangles. First one I'm going to draw is that one. It looks like it's in the second quadrant between pi over 2 and pi. And I know that my sine is the opposite over the hypotenuse. And I recognize 12 and 13 as being a right triangle, 5, 12, 13. But when I put the 5 in there, I notice that I'm in the second quadrant, and that 5 has to be a negative 5 because we're going to the left. On my other triangle, we notice that it's from negative 2 pi to negative 3 pi over 2. So I'm going to draw that one in the first quadrant. And again, I'm just drawing a triangle. It's not to scale. And my adjacent is 7, and my hypotenuse is 25. And again, I recognize that as the 7, 24, 25. So I'm going to put 24 in there. That's why I said you should memorize those ones that are used most often, so we don't have to use the Pythagorean theorem every time you have a right triangle, which is forever in all of this stuff. So now if I'm going to find my formula, I'm going to use my cosine difference, which is the bottom one. So I'm going to have the cosine of alpha. I'm going to call that alpha. I don't know if it is. And cosine of, delta maybe? I'm not sure. I should probably look these up. And then it's a plus because it's the opposite side in the cosine. So then I'm going to have the sine and sine. And so then to actually find some of these, I'm going to need to go to my triangle. The cosine, well, let's go back here. This first one is, this is that, and this one is this shape. Okay? So to find these, the cosine, I got to go to the right triangle. The cosine is the adjacent over hypotenuse. The cosine of the other one we know is 7 over 25. The sine of the black triangle is the opposite over hypotenuse. I think we knew that one. Times the sine of the green one, which is 24 over 25. And then to simplify that down, I'm going to end up with negative 35 plus 288 all over 325. Simplify, I get positive 253 over 3. And that's my answer. A lot of these aren't going to be nice answers because in trig there is a lot of other stuff going on. So if I'm going to prove this identity, so we have this identity that says this is what's going to happen. So we need to go ahead and simplify it if we can. Now, let's scroll up to where my cosine formulas are. So we have a cosine times cosine plus a sine times a sine. So if we're using the bottom formula, we actually have the right side of the formula up there where it says cosine, cosine plus sine, sine. If we look at the other side, if I'm going the other way using the formula, that's the same thing as the cosine of the first thing, which is this, and then minus the second one. So I'm going from the right side to the left side, and if I simplify in there, and they are the same. So I did simplify. Now there's the tangent formula, and if you're looking at your unit circle sheet with all the stuff on there. This is, where is this? The tangent one? Oh, it's to the right of the sum and difference formulas for sine and cosine. So it's to the right of that on there. And again, this is two formulas. It's not a plus or minus formula. And pay attention to, on the top it's a plus, on the bottom it's a minus, and vice versa for the tangent. So let's use it and see if we can find some answers. Now if we look at this, does this not look like that side when we use the top formula? So if we go backwards to the left side, I have the tangent of x minus y, and if we're using the top formula, we're using the plus sign in there. And then the second one is the y. And if I simplify that down, I end up with the tangent of x. All right. Because the formulas can be used going both directions. Let's start on 8.2, which is the double and half angle formulas. And you'll find those on my unit circle sheet right below where you had the sum and difference formulas. Now, when we get to the cosine ones, that's not just one formula, that's three formulas. So we know that this is the same as this, is the same as this, but you're going to want to use them in different situations. If you have everything in your formula in sine, you're going to want to use that one. If you want everything in your formula in cosine, you're going to want to use that one. And there's instances where you'll use that one. So there are two different formulas for this. All right, so take a look at those, highlight them on your sheet, write them down in your notes if you need to. And so we can use these formulas to simplify or sometimes find different angles. So there's lots of different forms. Take the time to write it down. Pause this if you need to. All right. So let's see if we can solve some of these. So if I want to find the cosine of 2, gosh darn it, there's another thing that I don't know, one of those Greek things. So I'm going to look at my formulas and I'm going to change it into the 2 times the cosine squared of whatever this shape is, a fancy y-looking thing, minus 1. And it just so happens I know what the cosine is, so I'm going to substitute that in there. It's negative 1/8 squared minus 1. And I can simplify that as 1/64 times 2 is 1/32. So 1/32 minus 1 gives me negative 31/32. Now, if I use the sine formula, I know that I can use 2 of this guy, cosine of the same guy. But wait, I don't know what the cosine is, so I'm going to go and draw a picture of the triangle that it comes from. And it says that it's in the third quadrant, so I'm going to draw something in my third quadrant. And I know that my cosecant is the adjacent over the hypotenuse. And if I simplify, I'm going to go negative 1 squared plus b squared equals 8 squared. 1 plus b squared equals 64. b squared equals 63. B must be 3√7. So we found that length, but before we start plugging it in, if we look at that triangle, notice that this is going down. So since it's in the third quadrant, my 3√7 has to be negative 7. So now I can plug into my formula because I already know what the cosine is. Now I know what the sine is. So I'm going to say 2 times the sine is the opposite over the hypotenuse times the cosine, which is negative 1/8. And so I end up with negative times negative is positive, so I get 6 root 7 over 64. I can simplify that to 3 and 32. There we go. Because both of them are negative, you have a positive. Negative times negative becomes positive. Now let's do the same thing for the tangent. Try to use red in this case. We know that the tangent formula is going to be, let me see here, the tangent to theta. That would be 2 times the tan of this cool letter all over 1 minus the tangent squared of this cool letter. And so we should go over to my triangle that I used to find the tangent. The tangent is the opposite over the adjacent. So I get negative root 3 over 7 divided by negative 1 gives me 2 times 3 root 7 over 1 minus 3 root 7 squared, in which case I'm going to get 6 root 7 over 963. 1 minus 63 gives me negative 62. And that would be 3 over 30, negative 31, simplified down. Okay. Now, let's find some half-angle formulas. Hopefully you wrote these down because I'm going to erase to give myself some more room. Alright, so if I'm going to use the half-angle formulas, again, go ahead, find the half-angle formulas. They're in the upper right-hand corner of my identities sheet. And the cosine half says cosine, I think I'm running out of time. I'm not going to be able to get all these done on this video. I'll finish this on the next video.